tí nữa Thành sẽ gặp các bạn ở trong nhóm số 8 nhỉ? Đó, Hân đây này, ở bàn này xong rồi. Phân chia công việc với nhau. Rồi trong bài hôm trước thì đang học về cái phương pháp, đúng không ạ? Cái mô hình dự báo RIMA. Okay. We're talking about the forecasting process using a RIMA models. So we have some basic step in doing the forecasting process for an RIMA model. Firstly, as we have discussed before, so RIMA model are only suitable for a stationary series. Okay, you can use those RIMA model to forecast for the future value of a stationary series. So in the first step, you have to check for the stationarity of the time series to see whether the series is stationary or not. So we will use the unit group test that we have discussed before to check for the stationarity of the series. Now, if the series is stationary, then you can design, you can specify the RIMA model for that series. But if the series is not a stationary series, then you need to transform it into a stationary series. There's many ways that you can use to transform a non-stationary into a stationary series. For example, you may want to take the first difference of the original series, or you may want to take the natural logs of the original series, or even you can take the first difference of the natural logs of the original series to generate a stationary series from the original one. After you have determined the stationary series, then we will specify the RIMA models for the stationary series. Okay, we will observe the parallelogram of the stationary series and then determine the order P and Q of the AR term and the MA term of the RIMA model. Okay, using the ACF and PACF plot. In the next step, we will estimate, okay, the models that we have specified in the previous step. Okay, we estimate it using eView, okay, using the ls command. Now, next we will check for the models, the model problems. For example, whether we have extract all the available information in the series by checking the residuals of the model. Okay, if the residual is a random series, then that is good. Okay, now we have to check for the highest lex order of the P and Q, of the AR term and the MA terms of the model. So if the highest leg order are significant, then you can keep it in your model. But if it is not significant, you may want to reduce the order of the AR term and the MA term. Okay. Also, we will consider the quality of the forecast, which is we will look at the criteria to evaluating the forecasting error, like MAPE or INSE. As we have discussed before, a value of MAPE which is less than 5% is a quite good number. Okay. Now, number 5. In the fifth step, if you have trust the model, you think that the RIMA model that you have built for your series is an appropriate one, then you can use that RIMA model to forecast for the future value of the original series. Alright, that is the basic step in generating the forecasted value for a time series using the RIMA models. Alright, now as in the first step, you may see that there are some some Riemann model that satisfy these requirements. Okay, so which one will be the most suitable one? Which one will be the most appropriate one to make to generate the forecasted value for the original series? Then let's consider some criteria that you can use to assess the appropriateness of a Riemann model. Now, the first one, the most important criteria is that the residuals of the model must be a random series. Okay, you can look at the parallelogram of the residuals of the model. So if all the autocorrelation coefficient and the partial autocorrelation coefficient are within the significant boundaries, then okay, you can be confident that the residual is a random series. Okay, or you may want to test for the autocorrelation. You may use some diagnostics test for autocorrelation and heteroscedasticity to check for the randomness of the series. Okay. Now, number two, the second criteria that we can use to evaluate an Riemann model is the AIC, SBC, or HATQ criteria. Okay, these are all built based on the forecasting error UI hat of the forecasting model, and then because it's based on the forecasting error, so the value of AIC, SBC, and HQ must be as small as possible. Okay, so which model has the smaller value of AIC, SBC, and HQ, okay, it will be a better one. All right. Number three, we will use the forecasting error evaluation criteria like IMSE and MAPE to evaluate the appropriateness of the Riemann models. Okay. All right. You can also plot the graph of the original series, the observed series, and the forecasted series generated by the Riemann model. Okay, you use the Riemann model to generate in sample forecasting. Okay, and then you compare the observed value of the series at different time with the in sample forecasted value. Okay, that you have generated to see whether the forecasted series chase the original series well or not. Okay, and especially you will look at the turning point, some turning point of the observed series to see whether the forecasted series can reflect those turning points very quickly or not. Okay, and also you compare the forecasted series with the observed series for the most recent period. Okay, if the forecasted value is very close to the actual value for the very old period into the past or some very far observation. So then, but for the most recent one, there is a deviation between the observed value and the forecasted value. Then it may not be a good forecasting model for the original series. Okay, we need in order, because we want to forecast for the near future. Okay, so we want the most recent observation. Okay, the most recent period, the observed value and the forecasted value must be close to each other. Okay, is so that the forecasting ability of the model, okay, is quite good for the recent observation, for the recent period. So we may believe that, okay, so in the near future, it can also generate a good estimation or a good prediction of the value of the series. Okay, and finally, you can look at the statistical significance of the coefficient. Okay, you want to see whether there's as many as the statistically significant coefficient in the model. Okay, we need the estimation coefficient, the estimated coefficient to be statistically significant. Which model has more statistically significant coefficient? That one will be a better one. Okay, all right. Now let's practice how to use the IRIMA model to forecast for the future value of the series. Now please use the work file KTE418 with the page IRIMA. We will again generate specify the IRIMA model for the GDP series. Okay, now open the file KTE418. Last time we have tried this one, but now let's do it again. Okay, based on let's look back at the forecasting procedure, the forecasting process using an IRIMA model. Okay, first you have to check for the stationarity of the series. If it is not stationary, then you must transform it into a stationary series. Like we have discussed before, there's many ways that you can use to transform a non-stationary into a stationary series. You may want to take the first difference, or you may want to take the log of the original series. Okay? Last time we tried the first difference, right? You may do the other way. Now in the first step, we need to check the stationarity of the original series. So we build the IRIMA model for GDP series. Okay, you go to view and go to unit root test. We will check for the stationarity in the level of the series. Okay, and p-value here is a large one. Okay. 0.87956. Okay, so the original series is not a stationary one. So we will observe the unit root test results for the first difference of the series. So maybe we want to take the first difference of the series to generate a stationary series. So here the p-value for the unit root test for the first difference of GDP is 0.000. Okay, it's less than 5%. So we can reject the null hypothesis, and we conclude that the first difference series of GDP is a stationary process. Okay. All right. Now in the second step, we will observe the cologram of the first difference of GDP series and choose the P and Qs of the AR term and the MA terms of the IRIMA model based on the ACF and PACF plot. Okay, so you go to view again and choose the cologram option. We will observe the cologram of the first difference of the original series. Okay, and click OK. Now this is the cologram of the DGDP, which is the first difference of the original series. We have AR1, we have the first autocorrelation coefficient, which is statistically significant. This one also, okay, the 8 autocorrelation and partial autocorrelation coefficient, and 12, okay. Now, let's estimate some of the model, okay. You can try some combination of the AR term and the MA term. Okay, let's try the ARIMA, this is ARIMA 1812 and M item 1812 also. Then we try the ARIMA 111, and then you may want to use the ARIMA 1812 and 0, or the ARIMA 011812. Okay, let's try some combination of the AR and emitter. The first one, LS, D, GDP. Okay, AR1, oops, AR8, AR12, MA1, MA8, and MA12. Okay. Oh, I forgot C. Thêm hệ số chẵn. Enter. Oops. This is the estimation result. We will now record the result, for example, in Excel, and then compare the appropriateness of this model. Now first, this is the model, and then some criteria to evaluate the model. Now, we have white noise, random residuals. Random residuals, the second criteria is AIC, SBC, and HQ. Okay, we can compare the MIPE of this model, and also we see the significant coefficient. Now first, for model ARIMA 1812, 1812. Với mô hình này trước, chúng ta sẽ check xem là có random residuals hay không. Check first whether the residuals is random. Go to view. From the estimation output, you go to view and residual diagnostic. We look at the kilogram of the residuals. Okay. Oh, this one, look at this. You have a random residuals. Okay. So we have yes. Okay. What about the value of AIC, SBC, and HQ? Now we again look at the estimation output. This is the value of AIC, HBC, and HQ criteria. So we copy this value and then paste here. Okay. Now what is the MIPE of this model? We have MIPE, go to forecast. Let's call the forecasted name, let's name the forecasted series GDP F1, okay? We will use the statistic forecast, okay, and click OK. Oops, MIPE of this one, very small value, right? 0.587%. 0.587%. But what about the number of significant coefficient? Look at this. Go to estimation output again. And we have 1, 2, 3, 4, 5, 6. Chúng ta có 6 coefficient và chỉ có 1 trên 6 coefficient của chúng ta là có ý nghĩa thống kê được. We have 1 out of 6 statistically significant coefficient. That is for ARIMA 1, 8. And also, you can line the graph of GDP and GDP F1, okay, and combine and compare the variation of them, okay. You can see that the GDP F1 here there are some point in the past where you see a deviation, a significant deviation from the forecasted value and the observed value, but for the recent time, the forecasted value and the observed value are quite close to each other. Okay, that's fine. But the only thing that we don't like this one, because it has too many insignificant coefficient. Okay. All right. Now let's try another model, that is ARIMA 111. ARIMA 111. Okay. Let's check whether the results of this one is a random one. So we will type in the command ls D GDP, C AR1 and MA1. Alright. Now this is the estimation result. Okay. We have to see whether the result is the random series. We go to kilogram of the residuals. Okay, now look at this. The autocorrelation coefficient and the partial autocorrelation coefficient at the 8 lags is statistically significant. And also the partial autocorrelation coefficient at the 12 lags is also significant. So this one seem to be a non-random series. So this one is not static 5. Okay. This is the most important criteria for an ARIMA model, and this model does not satisfy. And maybe these criteria are not important at all. The second model, the third model is ARIMA. Now let's try ARIMA. Because there's too many insignificant coefficient in the regression model, so we will lower the level of P and Q. So we will try ARIMA 1, 8. 1, 8. Oh, okay, now let's just see whether the residual is a random process. Now type in the command ls D GDP, C AR1, AR8, MA1, and MA8. still have many insignificant coefficient here. Now let's view the kilogram of the residuals of the motor. It is the non-stationary one. Non-random. It's one non-random because the autocorrelation coefficient and the partial correlation coefficient at 12 flags is statistically significant. So, you have no random series. Okay. Now let's try ARIMA 1, 8, 12, 1 and 0. Okay. Type in the command ls d/gdp c AR1, AR8 and AR12. Okay, now let's see whether the residue is random. Let's look better. We have, yes, random residues. Now what about the value of AI, CSVC and HQ? Go to estimation output. Let's copy the value of this. Let's see whether the MAPE of this one is a good one. Let's go to forecast. Let's name the forecast series GDPF2. We will use the static forecast, and click OK. Now the value of MAPE here is 0.613. Okay. 0.613%, and the number of significance coefficient